Okay students, let us start with our new portion in mathematical physics, that is limits. Now having studied function, now we are in a position to understand the use of limits in physics. Okay students, now let us start with a situation. Say you are moving from Kolkata to Delhi and your train is supposed to reach Delhi at 11 a.m. tomorrow, and you are starting from Kolkata today, say in the morning 11 a.m. Now when you are traveling from Kolkata to Delhi and you are supposed to reach Delhi at 11 a.m. as the time closest to 11 a.m. tomorrow, the distance is actually becoming shorter and shorter, and as you reach Delhi at 11 a.m. the distance ultimately becomes 0. Now students, in this case time is our independent variable. So time is not going to depend upon the distance between Kolkata and Delhi, but the distance x kilometer between Kolkata and Delhi is definitely going to depend upon time. So as time approaches close to 11 a.m. the distance becoming shorter and shorter or closer to 0. So students, here we are considering distance is a function of time. So we are writing ft, that is distance is a function of time. So students, here we can say ft approaches 0 as t approaches 11 a.m. Now students, we can say that limit of ft is 0 as t tends to 11. Now you should understand here what is the meaning of t tends to 11. This actually means that t is very close to 11 and not exactly at 11, because at 11 if t becomes 11 then actually the distance become Kolkata and Delhi becomes 0. So we are considering here as t tends to 11, that is t is very close to 11. Now students, let us try to understand what is the application of limit in physics. As from the above example, you can easily understand that when two physical quantities are present, one is independent quantity, say time, and another is dependable quantity, say displacement. So in this case, if we want to arrive at a specific point of time and we want to find out what is the value of a given function at that specific point of time, we can definitely apply limit in order to find any kind of changes. Now students, let us try to understand the algebra of this given limit. So students, this is our question. Calculate limit x tends to 1 x square minus 1 divided by x minus 1. Now in this particular question, if we take the value of x equal to 1 at the denominator, then you can see the equation x square, this particular equation x square minus 1 divided by 0. Now students, if we apply the limit x tends to 1, that is x equal to 1 at the denominator, then this particular equation x square minus 1 divided by 0 does not have any definition, because division by 0 is not defined at all. So how we can approach this particular problem? Let us see. So students, x square minus 1 divided by x minus 1 is not defined at x equal to 1. As I said that if I take x equal to 1, then the denominator becomes 0 and it is not defined, because division by 0 is not defined. So we already know we can write x square minus 1 equals to x plus 1 x minus 1. Now students, we can solve this particular equation as you can get x plus 1 after solving it, and remember x plus 1 for x is not equal to 1. Now students, we can write this particular equation, limit x tends to 1 x square minus 1 divided by x minus 1 equals to limit x tends to 1 x plus 1. Now from this particular equation we can see or understand that when the limit x tends to 1 on that time this limit approaches the value 2. So we can see here, as x approaches 1, limit approaches 2. Now students, let us try to understand a very important limit used in physics, that is limit x tends to infinity. Now what is the meaning of limit x tends to infinity? Now students, if you look into the graph shown here, this is a graph of a function fx equal to 1 by x. Here x cannot be equal to 0. So students, this is a graph of a function fx equal to 1 by x such that x is greater than 0. And as you can see, this is a decreasing function, and we have learned the basic definition of a decreasing function. In fact, it is a monotone function. Monotone function can be increasing or decreasing function, which we have already learned. So this is a case of a decreasing function, fx equal to 1 by x. So students, here as fx approaches 0, x gets larger and larger. So you can see here, this x is getting larger and larger as fx approaches 0. From this graph, we can easily understand the value of x is not finite, it is increasing and increasing. So we can write, in this case of fx tends to 0 as x tends to infinity. So we can write here fx tends to 0 as x tends to infinity. Students, here you should understand that infinity is not any real number. It only means it is just to indicate that x is becoming larger and larger.